So hello and welcome to our fifth lecture, our fifth class together. Today is September 14th, Math 211. I'm going to share my screen here and we're going to go for files. Okay, rules of counting. So the rules of counting you were okay with. That's not what your question is, right? Your question is more of the stuff that came after it. This stuff right here, right?
Yes.
Okay, so what exactly is your question?
I just wanted to do these questions again because I don't remember when we did them.
All right, so let's start from here. All right, so it says, this is a good review anyways. So there's n factorial ways to line up n objects. But if you only want to line up r of those n objects, you're going to only use the first r factors. And you get this formula here. So without worrying about why this formula is true, this just is the formula when you want to use only r of them, whereas this is the formula that you would use if you want to use all of them. So how many ways can 5 teachers be assigned to 5 classrooms? So if these are the 5 classrooms, how many choices do we have for the teacher that's going to go into the first one? This is clear. I'm sorry?
5.
5. Any one of the teachers can go into the first classroom, correct?
Yep.
And once that teacher has gone into the first classroom, how many options do we have for the second one?
4.
4,
And once those 2 teachers have gone in, how many for the third?
3,
And how many for the fourth?
2,
And how many finally for the last one?
1.
1. So in this case, we're lining up all 5 objects, which is why the answer is 5 factorial, which is also equal to 120. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120, correct? Yes?
Yes.
Okay. But now there's only 3 classrooms available. How many teachers can go into the first classroom?
5,
5. How many can go to the second classroom?
4,
And how many can go to the third classroom?
3,
3. So in this case, we're not lining up all 5. We're lining up 3 of those 5. So according to this formula here, it should be equal to n factorial. There's 5 teachers, so 5 factorial over n minus r, 5 minus 3, or 2 factorial, which is 60.
okay.
Does that make sense?
Yes.
Now, in the last case, it says 5 teachers are to be assigned to 7 classrooms. So in this one, what are we lining up? Are we lining up the classrooms or are we lining up the teachers?
The
It's-
teachers?
Well, 7 classrooms and 2 classrooms are left over. Right? There's 7 classrooms, but 2 classrooms are left over, which means it's actually the classrooms that we are going to be focusing our attention on. So the first teacher, how many classrooms can that teacher go into?
5,
7 actually, right?
7,
Because there's 7 classrooms. The second teacher, how many classrooms can that teacher go into?
6,
And how about the third teacher?
5,
And the fourth one?
4,
And the last one?
3,
So this actually becomes 7, which is the number of classrooms factorial, divided by 7 minus 5, or 2 factorial, which I don't remember doing it this way, so I might have been having a brain fart last time and got it wrong. Did I do it like this last time?
Yeah, you did it that way.
Oh, I did.
Well, I
Okay.
mean, not that way as in doing the underlines thing. No, you didn't do it that way.
Yeah, you
Did I
did.
get,
7 minus
But you
5.
got 7/2. Yes, you did.
Okay, I got, okay, so I was worried
Yeah.
that maybe I did it wrong last time.
No,
Okay,
you got the
okay.
same.
And what is 7 factorial over 2 factorial?
You got 2,520.
2,520. So there's 2,520 ways that 5 teachers can go into 7 classrooms, but only, so that, yeah, that's basically it. Does that make sense?
Yes.
Okay, so that was.
Wait, I have a question.
Uh-oh, yeah.
How is there like a specific way to know what would be N and what would be R?
Well, N has to be bigger than R, so that's the first hints, right? You have
Okay.
N object and you're taking R of them. You can't take more objects than you have to begin with.
Right. Okay, cool.
Okay, all right. So now that was about what are called permutations. Permutations, which is what we did last time, permutations are when the order matters. Okay, no drag racing in class, please, but
Sorry.
permutations are when the order matters. Okay, order matters for permutations. What's an example where the order matters? You know, you have a class of 100 students and you decide that you're going to pick a president, a vice president, a secretary, and a treasurer. So your first pick is president, your second pick is vice president, and so on. Obviously, there's a difference between first pick, second pick versus first pick, second pick, right? Because the order matters. Combinations, on the other hand, which is what we're doing now, are when the order does not matter. What's an example where the order does not matter? Well, suppose I have a class of 100 students and I say, oh, I need a big heavy table carried in, so you and you go and get it. Well, does it make a difference which of those two I pick before the other?
No.
No, the same 2 people are going to go either way. So when it comes to order not mattering, we use combinations. When it comes to order mattering, we use permutations. Now, on your calculator, if you have the same one I do, if you hit math and you go to the right to prob, we see that not only do we have that factorial button for 4, which we've done before, but look at 2 and 3. 2 is NPR. What do you think NPR stands for?
It's a permutation.
It's a permutation of N objects and you're picking R of them. In fact, let me go ahead and compute this value from the last problem. What should 7P2, oh, sorry, 7P5, what should 7P5 be equal to? Because we just did this like 3 minutes ago. 7 objects and you're picking 5 of them.
The 2000 something, but I forgot what it was.
All right. Someone chatted something. Did they give the answer? Yeah, 2520, right there. So this calculator has this permutation thing and the combination thing that we're about to do built in, which is kind of nice. So let's do an example of a combination. A worksheet has 5 problems, 1, 2, 3, 4, and 5. And you tell your students that they must do 3 of them, but which 3 is your choice? You pick whichever 3 you want. So when it comes to grading, do I care if you picked 1, 2, and then 3, or 3, 2, and then 1, or 3, 1, and then 2, or 2, 3, and then 1, and so on? Or do I just care which 3 you picked?
Just which 3?
Which 3? So the order that you do them in does not matter. So let's list all possible sets of problems the students might pick. There's 5 problems. I already gave you one, which is 1, 2, and 3. What's another option for which 3 they pick?
1, 4, 5.
1, 4, and 5. What's another option?
1, 3, 5.
1, 3, 5. What's another option?
Could you do like 2, 1, 3? Or since you
2, 1,
already
3, already have.
doesn't matter.
5, 2, 1.
Sorry, what was that?
521.
521, which is 125. Okay, I'm gonna put in numerical order. 521. Okay, what else?
413.
413. That's 134. Okay. So 1, 3, and 4. Okay, what else?
3, 4, 5.
3, 4, 5. Okay, what else?
2, 3, 4.
2, 3, 4. Okay, what else? Missing a few.
2, 3, 5.
2, 3, 5. Okay, anything else?
1, 3,
2, 4, 5.
I'm sorry, I heard two people at the same time. I didn't get that.
2, 4, 5.
2, 4, 5. Okay.
124.
1, 2, 4. Anything else? Well, if we can't think of any, then how many different ways can they select 3 different problems?
10.
10. In the previous case, when we had 5 teachers for 3 classrooms, how many different ways did we have in that example? I forgot. It was like last week. So what was the answer? How many different ways?
Was it 16?
It was 60.
Yeah.
So are these the same?
No.
Obviously not, right? So the question is, why or why not? Why is this not the same? So the answer is, this 60 is 6 times as much as 10, right? So we have 6 times as many options in this case as we did in the original case. Let's see if that makes sense. Let's look at just 1, 2, 3. How many different ways can we do 1, 2, 3 if the order does matter? Well, obviously we can do 1, 2, 3. Give me some other ways that we can do 1, 2, 3 if the order does matter.
2, 1, 3,
2, 1, 3,
3, 2, 1,
3, 2, 1,
1, 3, 2.
1, 3, 2,
3, 1, 2,
3, 1, 2,
And 2, 3, 1.
and 2, 3, 1. So what you see is that for the one situation in this case, there were 6 actual situations in this case. And the same one gives us 6. The same one gives us 6. The same one gives us 6. So each one of these 10, where the order does not matter, gives us 6 different ones when the order does matter, which makes sense why we should have 6 times as many options. Does that make sense? Now let's take a look at this formula right here, which looks like the permutation formula, but is a little different. If n is equal to 5 problems, and r is equal to 3, what does this formula give us? Someone read it to me using n and r for this problem.
You mean like 5 factorial over 5 factorial minus 3 factorial?
Well, wait one second. This isn't 5 factorial minus 3 factorial.
Oh, okay, so you just do it? Okay, so 2 factorial?
Yes, it's 5 minus 3.
Okay, so
factorial.
times 3 factorial?
And now on your calculator, what do we get? Or even not with a calculator, what's 5 factorial again?
120.
120. And what is 2 factorial?
2.
2. And what is 3 factorial?
6.
6. And what is 2 times 6?
12.
And what's 120 over 12?
10.
10, which is the answer that we got by brute force listing them. So we don't have to brute force list anymore because now we have a formula for combinations. We have a formula for the fundamental principle of counting. We have a formula for permutations. And now we have a formula for combinations. Oh, and by the way, on your calculator, what do you see just beneath the NPR?
NCR,
And what do you think NCR stands for?
this formula?
Combinations.
Combinations. So in our case, we're gonna do 5C3. And what do you think 5C3 is equal to?
10.
And there it is, 10. And so your calculator can do wonders. Can I erase all this stuff and move forward? Going once, going twice. Too bad. Okay. So let's do another problem. A coupon specifies that you have to buy a carton of 3 different types of Coke. You could choose from Coca-Cola, caffeine-free Coca-Cola, Coca-Cola vanilla, Coca-Cola cherry, Coca-Cola light, Coca-Cola zero sugar, Coca-Cola zero caffeine-free Coca-Cola zero, Coca-Cola. I can't even say that. You got all the different types. I was going to try to do it like really fast, but I couldn't do it. So how many ways can you select 3 different types of Coke? So what is the R in this case? And what is the N in this case?
N would be all the Cokes.
How many are there? 1,
14, 14 or
10, 12. I think
15.
15, right? 1, 2, 3, 4, 5, 6, which continues here. 7, 8, 9, which continues. 10, 11, 12, which continues. 13, 14, and 15. Some of those are just gross though. Caffeine-free Coca-Cola zero. Ugh. Anyways, and what's your R?
3.
3.
3, right? You got to buy 3 different types. So how many ways can you do this? Done. Ain't calculator's wonderful. $15 factorial over what?
12.
12, just number 12?
12 and 3.
The numbers 12 and 3? Can you be a little more specific with what you want me to write here?
Oh, 12 factorial and 3 factorial.
12 factorial and 3 factorial. Now, if you were to evaluate this by hands, would you really want to write out 1 times 2 times 3 times 4 times 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and get this huge number? And then the same thing with 12 and get this huge number and then divide them? Is that really how you'd want to do it?
No.
Not how I want to do it. So the question is there an easier way? And more importantly, is there a way for me to scroll up and have my writing go up with it? Anyone know? Is there a way to?
No, I don't think you can do that.
Well, I disagree with this whole option then. I don't like it. I'm not disagreeing with you. I'm just disagreeing with this, the way it's done. It's horrible. I'm gonna go up here then and continue my writing here. So I'm gonna give me a easier way to compute 15 factorial over 12 factorial than actually writing out and computing the top and bottom separately. Does anyone see it?
Yeah.
Yeah?
5 factorial over 4 factorial?
Where does that come from? Oh, no, 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 bad Alex, no. You can't just divide them by 3 like your regular numbers. No, 15 factorial is 15 times 14 times 13 times what?
Yeah, I see my problem. Thank you.
No, but I'm asking everyone, times what?
12,
Ah,
11, 10, 9, 8, 7, 6, 5, 4, 3, 2.
All of that I can call what?
12
Factorial.
factorial. And then you can
12 factorial. Right? I can write the 15, the 14, and the 13, but the 12 through 1, put it all together as 12 factorial, so that when I divide it by 12 factorial, what happens?
becomes 1 and they cancel out.
They cancel. And I just get the much easier problem, 15 times 14 times 13. Now, let's not forget, I'm also dividing by 3 factorial here. And what is 3 factorial equal to?
6.
6. So I have 15 times 14 times 13. And 15 I can write as what? How can I write 15? I can write 15 as 3 times 5. And I can write 14 as 2 times 7, right? Yes?
Yes.
And I can write 6 as 3 times 2, right?
Mm-hmm.
What's the point of doing that? It seems like it's not simplifying things. It seems like it's making it more complicated.
Well, Professor, I just did 15 and then I did the bottom and I put parentheses in it.
Oh, that's totally fine. That's
Okay.
totally fine. I'm just saying, I'm just trying to simplify a little bit, just algebra.
Okay.
What's the point of writing 6 as 3 times 2 and 15 as 3 times 5 and 14 as 2 times 7? How does that help me here?
They cancel out, don't they?
I can cancel them. So really all I have is 5 times 7, which is 35, times 13. And as we all know, without a calculator, what is 35 times 13?
455.
455. Can you explain how you got that without a calculator?
No.
No. What's 35 times 10? That's an easy, that's 350, right?
I'm sorry. Yeah.
And what's 35 times 3?
$105.
105. Now those are, I can do both those in my head. Could you? Those aren't too hard, right?
Mhm.
And how do I put this together
You add them.
to get that? So 35 times 13, which means 13 35s. That's 10 35s and 3 more 35s. Well, 10 35s is 350 and 3 more 35s is 105. You put it together, you get 455. Of course, if you do it in your calculator directly, you see that 15C3 is very quickly 455. And because calculators are allowed, you can always do that. But I personally, as a teacher, love to explain simpler ways of doing things and deeper ways of doing things, and hopefully giving you a deeper appreciation, which nobody usually cares about. So for that being said, let's go ahead and do the next one.
Just quick question, Professor, before you move on. You got the 12 factorial by subtracting 15 and 3, right?
That is correct.
Okay, perfect. Thank you.
So go ahead and write down what you believe the formula is for this next one right beneath it. You're designing an experiment to test 2 different ways to justify the rule for multiplying fractions. You will randomly select 5 students from a class of 10 fifth graders to teach using the first method. How many different groups of students can you get? All right. So who would like to venture a guess as to the formula that I should write down?
So the N is 5,
And what's R?
10.
So you want R, the number that you're picking, to be bigger than the number of options that you have to pick from?
No, I want N to be 10 and R to be 5.
Wow, genius. So N is 10 and R is 5. There's 10 objects. What are the objects in this case that you're picking from? What are your 10 objects?
10 fifth graders.
10 fifth graders. And of those 10 fifth graders, how many are you picking?
5.
5 of them. So when you get that group of 5, does it make a difference the order that you pick those 5 in?
No.
Then are we dealing with combinations or are we dealing with permutations?
Combination.
Combinations. So
I'm sorry,
therefore,
yeah, combinations, yeah, I'm
so
sorry.
therefore, we want the number of by the way, this is the shorthand. I didn't make a point of mentioning it, but if we go back up here, just in the formula, this is just a shorthand notation for combinations. Permutations does not have a shorthand notation other than the NPR. Combinations does. So that's just a shorthand. So what do we
And
get?
sorry, I have a question.
Yeah.
An example of like the order mattering in permutations is like the teacher's choosing a classroom, it goes 5, 4, 3, 2.
Yeah, well, because if I teach there and you teach there, that's different than you teaching here and me teaching there,
Yeah.
right? So it makes a difference which one goes.
Yeah.
But this
Okay.
one, I mean, once we have a group of 5,
It doesn't matter how you pick them or
Exactly.
which order. Right. It's a group of 5.
right? Which is why if you ever get into slightly more advanced stuff, like you're into poker, for example, the rules of poker, you can get a flush, you can get a straight, you can get a 3 of a kind, a full house. And the question is, why are certain hands better than others? And it's all about how rare they are. How likely is it to get these hands? But when I'm dealt 5 cards, the order that I dealt them in doesn't matter. It's all about
Right.
combinations.
Right. Right.
Anyways, so what is the
Thank you.
formula here? You're welcome. What's the formula here?
10 factorial over 5 factorial times
5.
factorial, right?
Yeah.
Pero no, like, you have to create all this so you can force
Pero
one
ella
to have
dice
each
que
other.
ella lo ha
And that's kind of fucked
visto,
up.
mira,
That's
ante
really
Dios,
selfish.
que me caiga un rayo ahorita aquí en seco, que yo no he visto que Ori agarrado 3 conchas.
Okay.
Porque si yo lo mirara, le dijera, está bien una, papá, por tu bien, no por el bien de nadie.
It's kind of fucked up.
Well, I'm just telling her, I told her, hey, mom, last time your mom said that she saw Orlin eating over 3 conchas in one day. And I told her, my tia last time was saying that
Hello,
Orlin
hello,
ate 3
we can hear
conchas.
you.
Genesis,
Hello, Genesis.
So that's a very interesting story. I didn't understand a word of it though. I only speak Hebrew. So next time, please speak in Hebrew. Maya, me and you, okay? Next time? You there? Okay.
Yes, yes.
Okay, so next time we'll have a story in Hebrew. That way, nobody will understand what we're talking about. I like it. Anyways, so what is 10 factorial over 5 factorial, 5 factorial? How do I compute that?
Ten times
and you
9
break down
times-
2 times 5, yeah, and then cancel out one of the 5s.
Break down what? I'm sorry?
Okay, so you do 10, you break it down to 2 times 5. Wait.
Well, no. This is a 10.
Oh, yeah, no, I'm sorry. Yeah, I just see. Okay, never mind.
98.7.
Yeah, never mind. I see.
6. The remaining 5, 4, 3, 2, 1 will cancel with that 5, 4, 3, 2, 1. And I still have the other 5, 4, 3, 2, 1. 5, 4, 3, 2. Of course, I don't get it right 1. Now 3 and 2 at 6, so goodbye. 10 over 5 gives me 2. 8/4 gives me 2. So I have 2 times 9, which is 18, times 2 times 7, which is 14. And what is 18 times 14? That's, I think, 252. Is that what it was?
Yep.
Right? 180, 10 times, 18 times 10 is 180. 18 times 4 is 72, and 180 and 72 is 252.
Oh, okay. So, in a sense, breaking it down kind of helps us in case we don't have a calculator.
Yes, and how often do you carry a calculator with you? Right, so how often are you gonna, see, for me, I always have a calculator with me, right?
Yeah, correct.
I mean, I don't leave home without a calculator. And plus you have your phones anyways with that calculator. But, next time you're stranded on a desert island, everything is, you have no cell reception or
Stranded in a desert island.
and you have all your, you lose everything. This way you can still calculate combinations and permutations, very important stuff. All right, I don't need to do this one, justifying the formula for combinations, because I really kind of did. So we're gonna go ahead and that means we're done with chapter 3. How exciting is that? Yay, that wasn't that bad at all. Was it? No, that was awesome. You guys had a great time, right?
Yeah.
So now, because we finished chapter 3 today, this of course means that your homework for chapter 3 is due in a week. Next Tuesday, I'm not collecting it, but it's when it's due in terms of, any quiz that I might give. The only question I have is, we have a quiz this coming weekend that was already scheduled from last time. Do you want it on 2 or on 3 or on both? Which of 2 and 3 do you find easier, and perhaps you'd rather have the quiz on that one? Because I can go either way. So we have a
3. I agree.
3.
3.
Okay, so this is a very close vote so far. Does anyone else wants to input their votes? 3, 3, 3, 3, 3, 3, 3. Do I have a 2? Does anyone want to give me a 2 here?
Yeah, I'll say 2.
Well, too bad. Okay, so nobody gives a shit what you say. So anyways, okay, so it's gonna be on 3, but just remember that I will not be putting up the solutions till a week from today, because I want you to have at least a week to do them. So if you still want it on 3, I'm more than happy to have it on 3. Or you know what we can do? I'll tell you what. I am so nice. Tell you what. The second quiz won't be this weekend. I'll give it to you Tuesday, but you have it till Thursday. So you don't have 5 days to do it. You only have 2 days to do it. That's the trade-off. I'll wait till Tuesday so I can put the solutions up. But
Wait,
then
could you repeat that? I'm so sorry.
I forgot what I said.
You said something and all I heard was days.
I think because this last quiz, I gave it to you on a Thursday and you had it till Tuesday, right?
Yes.
This one, I'm gonna give you on a Tuesday and you have till Thursday,
Tuesday till Thursday on chapter 2,
on chapter 3,
on chapter 3.
right?
So
What about
Chapter-
chapter 2?
There will be nothing on chapter 2.
Okay, okay.
We're only gonna have one chapter, basically a week, and we have more than 15 chapters. Just to be clear. Yeah, no, you're clear. Your writing is perfect. So you should have a period there at the end.
Professor, there's no way to have the quiz on Sunday.
Sunday, but the homework won't be due till Tuesday. So when are your solutions? When are you gonna see the solutions?
But I can't do it Tuesday or Wednesday.
Oh, because you're Jewish.
Yeah.
Jews ruin everything. Okay, let me think.
Sorry.
So it's okay. Just so everyone knows, I'm Jewish too. So that was a joke. I'm allowed to say that. Just, don't, think I was serious because.
Don't come for me.
Yeah, exactly. Oh, so you want it on Sunday. Okay, well, I can give it to you on Sunday, just for you.
Okay.
And everyone else will get it Tuesday. How's that? Okay? All
So
right.
then Okay, so the homework for chapter 3 is next Tuesday.
We do on Tuesday. On Tuesday, I'll put up the solutions and the quiz.
Okay,
Until Thursday to do the quiz.
okay.
Yeah, so that'll be like the compromise. So that way we skip chapter 2, but we do it on chapter 3, and it's not over the weekend. You have a shorter time and everyone's happy and yeah. So we're okay with that?
Yeah.
But how am I
Yes.
getting the quiz? Is it like you could just put it on Canvas just for me or?
I'll email it to you.
Oh, okay, fine.
Yeah, I'll email it to you. Okay, and then I'll give everyone else a different one because I have multiple quizzes. So you'll have your own, and everyone else will have a different one. Okay. All right.
I have a question.
Too bad.
Are we are we gonna be going over the first quiz at all, or?
You want to go over it?
I mean,
I can go over it. That's a
if
good.
more people want to, I mean, not
No,
just
no,
me.
Yeah, no, I'd be down to review.
Yeah, let's go over it right now. Let me find it. Hold on. I gotta stop sharing for a second just so I can find it. Hold on a second. So that was on quiz 1 PDF. Okay, so I'm gonna start sharing again. Okay. All right, so here it is. All right, so there are 3 questions, 50, 40, and 10. And I haven't graded it yet, but as soon as I do, the grades will go up. So write a sample space with equally likely outcomes for the situation of rolling 2 tetrahedral dice, each of which has 4 faces numbered 1, 2, 3, and 4. So the sample space is the collection of the following: 1 and 1, 1 and 2, 1 and 3, and ... up to 4 and 4. So there's 16 equally likely outcomes in that sample space. Construct a probability distribution for the difference of the 2 tetrahedral dice first minus second. So could I get a 0?
Yeah.
Yes.
Sure, 1 minus 1. Can I get a 0? Can I get a -1? 1 minus 2. Yeah.
Yeah.
Can I get a -2?
Yes.
Can I get a -3?
Yes.
Yes, 1 minus 4. Could I get a -4?
No.
No.
Could I get a 1?
Yes.
Can I get a 2?
Yes.
Can I get a 3?
Yes.
Are these all of them? So now, how likely is it that I get a -3? Well, the
1
only,
out of 16.
yeah, the only way to get a -3 is 1 and 4. So that's 1 out of 16. How likely is it that I get a -2?
2 out of 16.
Both, right? So that's 2 out of 16. How likely, what happened there? How likely is it that I get a -1
3 out of 16.
and 0
4 out of 16.
and so on, right? So this is
3, 2, 1.
and done. Okay, which of course add to 1. So, and so what's the probability to roll a difference of 0? The answer is 4 to 16. And what is the probability to roll a difference of 2 or more? Now, somebody emailed me over the weekend about this question, and I had to be honest, I didn't really remember the question. I probably should have looked at the page, because now that I'm reading it, I realize that the answer I gave you is not technically correct. So yours, I will grade differently. But when it says a difference of 2 or more, that's specifically the last 2 cases. 2 or more means 2 or 3. When this person asked me, I thought a difference of 2 included negatives or positives. Or maybe it does.
I put 3 out of 16. Would that be?
Yeah.
Yeah,
Same.
3 out of 16 is 2 or more. So
Yeah,
3
Professor, I was actually the one that emailed you about that. I
Yeah.
ended up, because you answered yesterday as well, I ended up submitting both of them. Because I
Okay.
submitted one, and then when you answered again, I submitted the other one.
Yeah,
You can see both quizzes, and
okay, I will accept 3 out of 16 and possibly 6 out of 16, because it was a little vague.
yeah. Mhm.
But wouldn't a difference of 2 or more wouldn't include negatives, right? Because a negative is less than 2.
Yes, technically, yes, but I could also see how a difference of 2, you might think of it as either way. I can see the person saying that, even though when they say here for the difference and they specifically say first minus second.
Yeah,
it
yeah,
only-
because first I submitted the one, and then when you say, yeah, include all negatives, that's when I resubmitted it.
Good,
Yeah.
so I'll just look at your first one then. Okay,
Okay, perfect.
excellent, okay.
Is it fine if we change the fraction to decimal?
Yeah, 100%, 100%, 100%. Okay. This one, very similar to what we did in class. Your students flip a fancy button, calling one side outside and the other side inside. And here are these first 6 flips. So what's the result of number 1? It's an outside. Second was an outside. Third was an inside. Fourth was a outside. Fifth was an inside. And sixth was an outside. So what is the proportion of outside so far?
1 out of 1.
1 out of 1. How many outsides so far after 2 flips?
2 out of
2
2.
out of 2.
2 out of 2. How many after 3 flips?
2 out of 3.
How about 4 flips?
3 out of 4.
3 out of 4. How about after 5 flips?
3 out of 5.
Genesis?
3 out of 5.
Yeah, but is that you talking, Genesis, right now?
No, it's my mom. I'm sorry.
Right. And how about 6?
4
I did it in decimal, so I got 0.66.
That's what they're fine too.
Yeah.
And then construct a graph like those in the lesson showing flip number and proportion. So the first flip, we're at 100%. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after first flip, we're here. After the second flip, we're still at 100%. After the third flip, we're at 67. 1, 2, 3, 4, 5, 6, 60, about here. After the fourth flip, we're at 75. After the fifth flip, we're at 60. And after the last flip, we're back at 2/3. And we start at 0. So 0, something like this would be how we did it in class. Does that make sense?
Yes,
So
just a quick question. Is it okay if we didn't do it like we put our own numbers in certain
yeah,
places?
yeah, that's fine. Doesn't it?
Okay, perfect. Thank you.
What is your estimate of the probability that the button lands outside? Well, if I want to use all of my data, which is of course better than using some of my data, then what's the answer?
67. I put 67%.
Yeah, 4 to 6, 67%, 66.6 bar percent, 0.66 bar, 0.67. I don't anything that indicates that you're using the last value to make your estimate will be the end of it. And the last one was just basically a
Definition.
yeah, fill in the missing word to describe the law of large numbers as it is applied to flipping a fair coin repeatedly. So your answer must be in this context. As the number of flips increases, the proportion of heads approaches 0.5.
What I put the probability of heads approaches 50%.
Fine, that's good. That's good. Okay. So that was
Which
quick.
one?
It wasn't bad, right?
No, it was good. Thank you.
And the other quizzes are going to be similar. No surprises. If you understand what it is that we do in class, the quiz in the homeworks, the quizzes are going to be based upon them. So let's go ahead now and start chapter 4. The addition rule. So, chapter 4. We did already the multiplication rule. It seems a little strange, maybe, that we do the addition rule after the multiplication rule, because when did we learn addition? Like in, I don't know, nursery? And when do we learn multiplication? Like in what, 3rd grade or something? So now we're doing it in the opposite way, because when it comes to the types of problems that we're working on, it's actually easier to do the multiplication rule than it is to do the addition rule. So let's take a look. The meaning of and or in mathematics. So supposing you select at random a digit from 0 to 9. There's 10 digits here. Equally likely. That's what at random means. There's no tendency to have one over a different one. So every one of these 10 is equally likely. What is the probability that it is even or a prime? Now, I'm not looking for two different answers. I want one answer here. Even or prime makes me happy. So let's go through all of them and decide which of these 10 numbers make me happy. Would a 0 make me happy?
Yes.
Why? I'm not saying you're wrong. I'm just saying why.
It's prime.
It's not prime. Oh, well, hold on a second, buddy. 0, no prime. 0 is what?
Even.
0 is even. How about 2? Is that making me happy?
Yep.
Yeah, why?
Even number.
Even.
It's even. And by the way, it's
And the prime.
prime also. It makes me happy twice.
Mhm.
Okay. How about 4? Make me happy?
Yep.
Yeah. How about 6?
Yep.
How about 8?
Yes.
How about 9?
Yes.
Really? Is 9 even?
No.
Is it a prime?
No.
Then why is it making me happy?
I'm sorry.
I'll forgive you. So 9 is out. What about 7? Does that make me happy?
Yes.
Yes,
Why?
it's a prime.
Okay. How about 5? Make me happy?
Yes.
Why?
It's prime.
Okay. How about 3? Does it make me happy?
Yes.
Why?
Prime.
Okay. How about 1? Make me happy?
Yes.
Why?
Because it's prime.
Actually, it's not.
No, it's not prime.
Right? 1 is not considered a prime number. This might surprise some people, but it's not prime. The first prime is 2, or the smallest prime is 2. Not necessary for us to go into why 1 is not considered a prime number, but just fact, 1 is not prime. So what is the probability that the number I pick is either even or a prime?
Eight out of 10.
8 out of 10. 4 out of 5, 80%, all the same. Do we agree?
Yes.
Now, what is the probability that it is even and a prime? So I am only happy now if it's even and a prime. What is the probability that the number I pick is even and prime?
2.
2? Just straight up 2? It's a
No,
big-
I'm sorry. I'm
1 out of
counting. I'm
10?
saying 2. There's 4. There's 6. There's 8. So there's 4 out of 10. If I count it right.
Well,
That's
is
even and prime.
4 prime?
It is, isn't it?
1 out of 10. But it's just 2.
Just 2. 2 is the only number on
Oh,
this
wow.
that is both even and prime.
Oh, okay.
So when we say and in mathematics, whatever we're looking at must satisfy both. So and implies both. For it to satisfy an and, it has to satisfy both. For it to satisfy or, it must satisfy what?
One or the other.
One or the other, but you got to be careful there. Because in English, or actually has two different meanings. If you go to, if you are signing a form and the form says, are you over 40? There's two options. Either you are over 40 or you're not.
Excuse the interruption. The high school girls volleyball game for this afternoon
Sorry.
has been postponed. Training will resume as normal. Thank you.
You're welcome. Okay, so if you are signing this form, you're either over 40 or you're not over 40. It's impossible to be both at the same time, over 40 and not over 40. Correct? Yes, right? It's one or the other, right?
Correct.
Yes.
But if I go to a restaurant and I'm deciding what to eat, and they say, do you want a hamburger or a hot dog? What do I say? Look at me.
What if I want both?
Yeah, look at this, right? What do I say? I say I want both. Okay, or means both in my case. Okay, so in mathematics, when we use the word or, it means either or both. It's not the exclusive or, it's what is called the inclusive or. Does that make sense?
Yes.
Okay. Now, is everyone here familiar with what a Venn diagram is?
Yes.
Okay, so let's make a Venn diagram for this situation. I'm going to make one circle, and this circle is going to be my even number circle. I'm going to make a second circle, and this circle is going to be my prime number circle. And out here, I make a U to indicate that the entire rectangle is the universe for the problem. It is the entire universe. There is nothing else. So I'm going to put all of these numbers in one of how many spots are there in the Venn diagram? How many different sections are there in this Venn diagram?
4.
There's 4. There's the outside. There's here. There's here. And there's here. So let's go through them. Where should 0 go?
Even?
0 is even, but even has 2 parts. It's here and here. So which of these 2 parts should it go into?
Even
Just
alone.
even.
Just even and not prime. How about 1?
Just
Even? Was it even?
Well, 1 is certainly not even. What number?
What's the prime?
Outside of the
on the
box.
outside universe.
Oh, the I see. Okay.
What about 2?
And the middle.
In the middle, because it's both even and prime. What about 3?
Is a prime.
Is it in the middle part prime or the outside part?
Not just prime.
Just prime. How about 4?
Even. Just even.
Just even. Okay. 5,
Prime. Just prime.
6,
Even. Just
7,
even. Prime.
8,
Even.
9.
And the unknown universe world.
Yeah. Well, just to be clear, the universe is everything.
Okay.
Okay. But these guys here, not being in here, here, or here, are just in the 4th section. But the universe is the entire rectangle, including the circles. The universe is, right, those numbers. And every number has a place. Does that make sense?
Yes.
Okay.
It inhabits everything.
I'm sorry, one more time, say that again.
It inhabits other numbers.
Yes, everything has to be somewhere because everything's in the universe. Okay,
Professor,
yes.
I have a question. How do we know when the number is like 2, that it's a prime and it's an even number? How do we know when a number is like that?
So are you asking about what it means to be even, or are you asking me what it means to be prime?
Prime.
Okay, so prime numbers are numbers that only have precisely 2 positive factors. What that means is as follows. Give me 2 numbers that multiply to get 2.
1 times 2.
1 times 2. Give me 2 numbers that multiply to get 4.
2 times 2 and 1 times 2.
Okay, 1 times 4 you mean, right? So once you have something besides just 1 in the number, it's not prime. The prime numbers are the ones that you only have one in that number, nothing else.
Ah, okay. Thank you.
So you always have 1 and 8, for example, but you also have 2 and 4.
And one,
Sorry?
you said that one wasn't a prime, right?
1 is not considered a prime. That's why when I said my definition, I said it has to have exactly 2 factors. And 1 only has 1 factor.
Makes sense.
But the reason why 1 is not considered prime is actually a little more sophisticated than what we need. So there's no reason for me to go into it. Just remember that 1 is not prime. Because on a quiz or something, if I say, you know, what's the probability of a prime, and you say this number because you thought 1 was, you will get it wrong. And I'm giving you fair warning now. So let's do another example. Suppose you pick a digit at random from 0 through 9. What is the probability that it is even or odd?
%100%.
Yes, every number is even or odd, right? Even, odd, odd. Every number is even or odd, correct? So it's 10 out of 10, 100%, point, you know, whatever number you want to do. How about that it is even and odd?
0 out of 10.
It's impossible to have even and odd at the same time. So 0 out of 10. Let's make a Venn diagram to illustrate this. We have our universe. The universe is 0 through 9. How many circles am I going to have?
2.
2. What are they going to be labeled as?
Even and odd.
Even and odd. Now I'm going to draw them with an overlap, even though there's not going to be anything in the overlap, because I know that there's nothing that's both even and odd. Where does 0 go?
Even.
1? Oh, I put the wrong spot.
Odd.
0 is, I saw this on here and I'm like, oh, 0, that goes in 0. 0, 1, 2, 3. Let's just put them in random spots just to remember that it makes no difference where they go in the section as long as they go in the right section. Does that make sense?
Yes.
Okay. Now, what are mutually exclusive or disjoint events? The term disjoint or mutually exclusive means 2 events that cannot happen at the same time. For example, if I roll 2 dice and I say I got a 7, and I also got doubles, what do I know about getting a 7 and getting doubles?
Doubles don't make up a 7.
Yeah, it's impossible to have a 7 and doubles at the same time. You can't roll 2 3.5s, right? Doesn't work that way. So rolling a 7 and rolling doubles are disjoints. They are mutually exclusive. They cannot both happen at the same time. Suppose you roll 2 dice. Decide whether the pair of events below are disjoints. Sum is 10, doubles. Disjoint or not disjoint?
Not disjoint.
Can you give me an example of getting both at the same time?
5 and 5.
5 and 5, right? In fact, that's the only example of getting both at the same time. How about prime and doubles? Disjoint or not disjoint?
The sum has to be 10, right?
I'm sorry?
The sum has to be 10.
No, that's a different example. This is a new example.
Oh, okay.
Be
1 and 1.
Yeah, 1 and 1, you can get doubles and still get a prime. How about we pick a card from a deck of 52 cards? An ace and a heart, disjoint or not disjoint?
Not disjoint.
How would I get both an ace and a heart at the same time?
I need cards. Oh, no, yeah, you can.
How?
You can get an ace and like a 4 of hearts.
Well, you're picking one card. You pick one card. Can you get an ace and a heart at the same?
Oh, no.
No, you can't.
No, how about the ace of hearts?
Yeah, the ace of hearts.
How about the ace of hearts?
Because there's the ace of spades, the ace of hearts, and what else?
Right, the ace of
I
hearts.
don't know the cards that well, but
There's clovers and there's
diamonds, right? If I'm not mistaken.
diamonds.
Yeah. Okay, there you go.
Hearts, spades, clubs. The point is,
You could get it.
you could get an ace and a heart. Can you get an ace and a jack at the same time?
No.
No.
No, this one's disjoints, not with one card. Okay, so which Venn diagram of these two represents disjoint events? The first one or the second one?
Second.
The second, because you can see there's no overlap of A and B. Okay? Let's just finish this page here. Shade the regions of the Venn diagram 1 that represents A or B. If you were to shade in A or B, what would you shade in diagram 1?
The parts that overlap.
This part here?
Yeah.
Okay, is she right?
What would it be? Everything?
Everything, including the outside?
No.
So what do you mean? You mean just this part here and this part here?
Yeah,
Yes.
not the middle, because isn't that and? Then you said it was
Well,
both.
the,
Oh,
ins-
isn't it all? Wait, let me see.
the inside,
Wait, one-
the overlap is and, but remember, or includes ands. Because or equals either and, or either or both. And the overlap is the both. So when you do or, it's anything. It's here, here, or here. What's the A or B for the second one? What would I shade?
Each one of them, but separate.
Yes, exactly. Very good. So A or B, there's no overlap. Now, if they are disjoints, then what is the probability of A and B?
0.
0, because they can't both happen at the same time. And if they are disjoints, what's the probability of A or B? This one's a little tougher, and you know what? I gotta run. So we will end here and we will start exactly here. So someone remind me, we'll start exactly here next time. Okay?
Page 4, right?
I think so, yeah. Okay, so I'm gonna go switch rooms. If anyone wants to stick around for office hours, I'm gonna be there in just like 5 minutes, but I gotta run. And hope you had a good day and you learned a lot. And I will see you either in office hours or I will
See you Thursday.
on Thursday.
Thank you, Professor.
Thank you,
Thank
Professor.
Thank you.
Bye, guys.
Thank you, Professor.
Bye. Okay.